Hello everyone. So today's problem is minimum number of operations to move all balls to each box. Now the problem statement is you have n boxes. You are given a binary string boxes of length n, where boxes of I is zero, and if the box is empty and one, if if the box contains one ball, it is one, right? If one operation you in one operation you can move one ball from a box to an adjacent, and box I is adjacent to it's a basic term. So return an array answer of size n, where answer of I is the minimum number of operations you need to move all the balls to the ith box. Each answer of I is calculated considering the initial state of the boxes, right? Okay, so it's a basic term, like it's given pretty simply. Like you have a binary string where each element is either one or zero, and we need to calculate the amount, like the number of steps we want to do or we are required to do to move all other ones to that specific box. Okay, so what it means is like, let's say we have 1 1 0, right? So let's say we have this array, right? This one, for this one, the moving state is zero, right? Zero. For this one, right? For this zero, one, and two. So for zeroth index, the moving state is zero. The number of steps is zero. For for one at index one, we need to move it one time, right? So it will be one. Zero, so it does not contain anything. So we don't need to move it anymore. Okay. This this one is done. Now for this one, we need to move all other ones at index one. So how many steps? Like we move this index to here, this one to here. So this will be our one. And we don't need to do anything for the zero and don't need to do anything for this one. So here it will be one. For index two, we need to move this one here, right? So it will be one step. And we need to also move this one here, right? So it will be one and two steps. So it will be two. The overall answer for this is 1 1 3. And that's how we obtain our current answer, 3. Okay. Now, how are we going to approach it? Okay, let me move all. Okay. So what we are going to do is, like, let's say we have an array. Let's say we have an example 1 0 0 0, right? And again 0. Okay. Now let's say we want to move this one here, because at some point we'll need to move all the ones to this array, like, right? Let's say we have all done imp the moving of all the elements, like, let's say we are done for this index, this index, this index, right? This index is done, this is done, this is done, this is done, right? Now for this one, how many steps we need to move forward to get to this index? On. Yeah, right. So what we will do is we will take our current, right? So we initially don't need to move anything, right? So there are total number of zero ones. Okay. Now what we will do is we will check if there is any one on the uh, left hand side, like we are leaving any one here, right? So let's say we don't need to move anything at zeroth place, right? Now what we need to do is we need to move one to here. Okay, so let's say we move our one to here, so total number of one steps, right? Then again we need to move this one here, so total number of two steps, so here it will be two, right? then again it will be 3 here, then again it will be 4 here, right? So what are we doing? We are progressing here in a linear manner, right? So every time a single one is moved, it does increase its steps by the same number of ones we have. So for another example, if we take this this method, right? So what we will do is we'll move this one to here. So let's say we have this, right? So for first we have 0. Then this one we need to move, this one we need to move here. Okay. So how many steps will it be? 1, right? Now what we have is again 1 here, right? So total number of ones is 2 here. Okay. So we have two ones and we need to move here. So two ones, how many steps we will require to move two number of ones to a next step? It two total number of two steps will be required, right? Because one for each and one for each, right? So it becomes two. Now same thing applies to three. When these ones accumulate at this index, right? So let's say we have three number of ones here. So when we move it to the next place, we will require total number of three steps, right? So total number of three steps will be here 6, right? Like let's say one goes here 1, here 2, and here 3, and here 4 and 5, like something like this, right? So this is the method, like, and this method we go from left to right as well as right to left, because for every index, right, we need to move from left to right and right to left. The total number of ones we need to calculate is like every ones on the left and every ones on the right. Okay, so let's try this in code. I'll explain it on the way. Okay, so let's say we have something as the our current, right? So this current is like our current accumulated number of ones. Okay, so accumulated as in how do we say? Accumulated as in the total number of ones we have previously, right? So okay, and we also need a variable to calculate the total number of ones. Okay, ones, right? And we will take a list here to accumulate the total number of steps. And let's create a variable for len of boxes. Right. Now we'll iterate through the list. Okay. Now we will append current, because at first, on the first index, we don't need to move anything, right? Because there is nothing on the left, and the one at index 0, this one at index 0 does not need any moving at all. Because at first we are moving from left to right and then moving right to left. Okay. So this is for moving left to right here, left to right. Okay. Now we will check like if items is 1, right? And if it is 1, we will increase the total ones to 1, right? And what we will do is we will add our current plus equal to total number of ones, right? Why this? Because like every time, let's say, right, like every time, let's say 1 0 0 1 1 1 0 0. Okay, so why we are adding to current with total number of ones? Because at first we only have single one, right? So the current amount of one is 1. So we will only need to make one step. But when we reach here, so there are total number of ones is 2, right? So for each one we need to make 2 steps. Oh, hope you got that, right? So that that's it for the left to right. Then again, we will set our current to 0. Then again, we will set total ones to 0. Okay. Now, we'll go from right to left for I in range. So, in -1, comma -1, and comma -1. Right. It is the same code, but as we have appended like the total number of indexes, we will only need to do some kind of operation on it. So at last index, what we will do is we will add our current. So from the last also it is similar situation. Like we don't need to perform anything on the last index, whether it is 1 or 0. So that's why like 0 we have added. And it's the same thing if boxes of I is equal to 1, then we increase the total number of ones. Okay. And our current increases by the total number of ones we have. Okay. Now, when we return ls, so this list will contain all the elements accumulated from left to right. Okay. Let's run it. It is accepted. Let me show you like at each step how our list looks like. So from left to right, after left to right, so it will give us, let's say, our current ls, and again after right to left, how it will look. Okay. See. So at like first we have uh, uh, 1 at index 0, but we don't need to move it at all. So because we are traversing from left to right, and at index 1, we only need to move this one here, right? So that's why we have added 1 here. And now we have two ones that we need to move to the index 2. So for this one, it will only take one step, and for this one, it will take two steps. But as we have accumulated this one here, and we have already added one here, so the total number of twos, and we need to move the total twos at last index. So that's why we have gathered here three. So instead of calculating the distance one by one, we can directly move this one here. Okay, then when moving from right to left, we have added 0 here because there is nothing to add on the left hand side, and we have added 1 here because like this 0 does not need moving at all, so that's why this one stays the same. Okay, and for this 2, like we need to move this index 1 at index 0, so that's why we have got 1. So even if for a different example, you can see a similar such thing, right? Like for first three elements, we don't need to move anything because this one only is counted when it moves from this to this index 2 to index 3. Okay, so that's why like the one which was at index 3 is counted as one, this one step. And when it is moved to this index 4, it is counted as another. So that's why two, total number of two steps. So this is from left to right, and this is from right to left. The uh, on each index, when you accumulate values from left to right and right to left, you accumulate the total number of ones on the right hand side and on the left hand side because of the intersection. That's it from my side. So thank you everyone. Please share and subscribe. Yep.